Welcome to the Databricks Skill Builder series. We're glad you're here.
As I said, we're going to talk about organizing for performance and cost. So we'll look at some of the techniques and considerations that we would like people to think about for the performance and cost. And I'll just mention a little bit of roadmap of our future roadmap for observability of your usage of Databricks, because I know that's a hot topic for a lot of our customers. So really what we're going to talk about is the motivation of why this matters, of why you want to look at and some of the challenges that we have of the looking at the pricing and overview, the challenges that customers face, some of our cluster management best practices, and then a little bit of performance and tuning and how you can use both Ganglia and the Spark UI to see what's happening in your clusters and some tips and tricks. Now, I do want to pause and say that we have been putting in private preview and releasing our serverless SQL. So that is something that we would like our customers, if you haven't talked about serverless SQL with your account team, that's something that definitely to reach out to them and talk, because this is when we think about some of the more traditional Databricks cluster management and optimization, different from serverless SQL, that can be a great option for a lot of customers. Okay, so with the background of this, it's important to note that there's really not a silver lining or a drop-down algorithm where you can just plug in parameters and get a perfectly architected cluster for optimization. So with all the different types of use cases that customers have, the data, the business needs, there's not a one size fits all. So we suggest customers think about some different questions. The SLA, how fast does this job need to run? Can you throw more cores at the job? You might get more speed, but that might not be worth your consumption cost. The type of job. So this is a big one. And again, this is where also take a look at serverless SQL that's coming out. But if our goal is to allocate just the right amount of cluster size for application, you want to think about how the data is going to be used. Streaming, ETL, SLA, service level agreement. So what is how fast does your data need to go to your customer? So if you're doing data engineering or ML, how fast does it need to be landed in Databricks, and someone needs to be able to have it fully cleaned or have processing or whatever those type of agreements are. So some customers might have, hey, I only need to refresh this data once every 10 minutes. Maybe it's once a day, or maybe that's really a couple of seconds that data needs to be available. Okay, and so with the other options or the other considerations to think about is experimenting is actually relatively cheap. It's when you're on Databricks, getting a rough order of magnitude of the size of your jobs is important. But remember that spending too much time to get that perfect cluster might be delaying your development. And you might just want to get that experimentation and see how that cluster is performing. Change considerations. So where do you want to make changes? And I have a little bit further details on this. Performance can be gained in a lot of parts of the platform, infrastructure, and your application. So there's code design. There might be faster ways to make an application. There's shuffle tuning. There's some edge features on Databricks that, on Spark, and how you can really get into your Spark cluster and tune it. There's cluster types and cluster sizes, data storage and format, and your application design. So these are all the different considerations. I have a slide later that kind of gives a pyramid of how we suggest you build these types of changes for your best performance. And lastly, Spark is intelligent, and Databricks, we have been working on constantly improving our runtimes and building this into Spark and into our runtimes. So You do want to let Spark do its job. So there's a lot of performance that you're going to get just straight out of the gate. And we always suggest one of the best ways to get performance is, if you can, experiment with most recent runtime, because we just roll in our optimizers and a lot of different deep level optimizations in Spark into our runtimes. So really from this background, high level, the main takeaway is there are a lot of best practices and optimizations, and you should always assume there's going to be some testing and experimentation to figure out where you land and how to best use your time. Okay, so performance requirements. So what you really also want to think about is, what does good performance mean, and where does that mean in your development stack? So with the most expensive part of big data analytics is really the resources, the people here that are probably attending this webinar. So this is commonly left out of the raw cost of running your data, but it really is a big part of your total cost of development. So just think about how much time people are spending to tweak out that development time. So ecosystem, this amounts to the time and throughput of processing needed in order for the component of this architecture to not be the bottleneck. So what that means is there something in your ingest before you land in Databricks, or is there something in the other end on the right side of the consumption that is actually being a bigger bottleneck for that time with SLAs or cost? And this goes a little bit back to the SLAs, the business performance. What is the speed of the business? Is that the real time? Can the job run overnight? There is really a price for performance curve that Databricks follows, because you can scale up and out. So how fast you want it might cost you more. So that's just, what does the business need and how much are they willing to spend on that? So this is kind of a foundation of how we recommend customers think. The foundation is on the bottom, that file layout. There's a lot of, what can you do with Z ordering? What can you do with your data once you put it in your blob or S3 storage? Then the next layer is, we have code optimization. Are there ways that your code can be written faster to utilize, say, Spark UDFs or something like that? And finally, this last top tier is this cluster sizing. That is actually what we're focusing on for the bulk of this talk, because then we're going to go in and look at Ganglia and how you can see this in Databricks. But in the slide deck, I do at the end, because it can be sent out, have slides on the foundation of file layout and code optimization with some best practices. Okay, so high level, what are the basic ways of cost and performance at Databricks, the elements? There's really three basic elements to the pricing. How much do you get charged? And this is a combination of the DBU, which is Databricks unit. That's the charge that you see from Databricks of how much does it cost to run Databricks. And then there's also your cloud provider costs, which is your cloud virtual machine. And also you have your data storage in the cloud. That cost is jobs on Databricks. Are you running automated versus interactive? Our customers have their own pricing SKUs for these different ones, but interactive is more expensive than automated. And interactive is just what it sounds like. It's the ones that we're in a notebook and you're running cells and it has that interactive feel, versus automated where you're kicking off a notebook and running a job. Those have different price SKUs. And again, this is one of those, reach out to your account team if you're not sure of what your pricing is on those. And then another one, choosing the right cluster, the hardware and the runtime considerations of when you spin up a cluster on Databricks. So this is a high level Databricks pricing of, we have a link here that will just say, what is a DBU? It's a Databricks unit. It's a normalized way of saying, how much does it cost to run X unit of compute on Databricks for a certain VM. So we have links here that will actually go in specifically how those are computed. And when you start your clusters, you can see this is a 0.2 dBu or 2 dBu, or you see how that is actually pricing. And so then the Databricks versus the cloud vendor billing, the different clouds bill differently, but that's where you see your VM costs and your storage costs. And then these DBU pricing tiers, I briefly mentioned this before, but we have the all-purpose compute, which is also called interactive, jobs compute light, Delta Live tables, and SQL compute, or SQL endpoints, depending on which terminology you're using. So these have these different pricing tiers. The web pages do the list pricing. Again, your account team might know if you have a discount or something with your cloud vendor or with Databricks, but those will give you the base pricing. You can see how they compare against each other.
Hey, Carrie, in the compute page, can you show that it had like where the DBUs are? Just if you open up like
Sure.
Yeah, look in here.
So right here, this is a compute that I've had started, and you see over here that we have the workers and drivers, and it says this 3 to 9 dBu per hour. And that was, I'll go back and create it. And the range is because we can scale up on this cluster from workers and drivers. So I'm just going to go over here and just do a create compute so you can see where if you start looking at this, when I click on this, you can see that this will start changing over here. So you can start seeing that over on the right, it changes this compute the DBUs. In general, there's things that, like GPUs are more expensive and such type of things, but the web page shows this, but you can also see in the dropdown.
Thank you.
Of course. Okay, so high level cluster management and best practices. So a little refresher of cluster basics of what is a driver and what is an executor, or sometimes called a worker, depending on terminology. And a cluster is a collection of instances. On AWS, it's EC2, or on Azure, it's VMs. So we have a question that what factors should we consider when specifying the driver node? So a lot of times we do recommend that the driver node be the same as the worker nodes. And you can start to think about, do you think you're CPU bound or memory bound by the type of workload you're running? And then you can see in the dropdown, we have different classifications and groupings for that. You can also go to the web page and see what those different what recommendations are for different types of workloads. And then that's that experimentation we talked about, that you see how well am I utilizing the cluster, which we'll get into talking about how that cluster utilization, how you can see that in the Ganglia and the Spark UI. So I chose my cluster, I ran some workloads. Now I'm going to take a look and see, did I utilize this fully? Am I using all my memory? Am I using all my CPU? Am I getting bounded by one of those two? And so for, with the driver, and the driver is the leader and it's coordinating the executors. So sometimes that can be the bottleneck of your job. Sometimes we see that when people are running data science workloads that aren't actually designed to go scale to the executors, it might all be running on the driver. And so that's a case, if you don't want to go use a distributed ML, you might want to scale up your driver very large, because you might need a big CPU or a big memory, or you might want to look at your code base and say, I want to design this so it can scale and use those executors. The second bullet, the driver is used for operations that consolidate the data. So when you in your code say collect or other functions, you're going to pull data from the different executors, you're going to pull it back to that driver, and it's going to show it there. And sometimes that can be a costly instruction. And at the end of the slide deck, if I don't get to it, it will be sent out. That's one of those coding for production things that we like people to look at, is check to see that you're not accidentally collecting data to the driver when you don't need to, because now you've gone to development, or I'm sorry, in production, you don't need to necessarily have that collection where you might want it in experimentation. So executors, workers, they are doing the actual work. So that's where we get this able to, in the cluster, when I was showing that create a cluster, this min worker, max worker, again, the terminology changes on depending what documentation. Worker is executor. You know, with this one, you're saying I want a minimum of 2, but I can scale up to 6 if I was creating this cluster. And this is a drop down. This is, you know, you can change this to whatever you want these workers to scale to. Keep in mind that that is, you know, the more, because you're charged for Databricks unit per executor. So that is where you see those charges will scale up. But also keep in mind that one of the strong benefits of using Spark and Databricks is that the executors and workers can scale up when you need them to and back down. And that is why you see this min and max worker. So if I really need to have this quick turnaround of my data processing or my ML training, you can have this max worker scale way up and say, I'm just going to take that hit on price. I'm going to pay a little bit more, but I'm going to get this done faster. Or you can be very price conscious and say, nope, min of 2 workers, max of 2 workers, and we're going to stay at that, or max of 4 workers. So that's where you can start looking at how are we utilizing this cluster. But you see right here, we have this enable auto scaling. It will scale between the minimum and maximum.
I've got a question. So I
Okay.
noticed that it shows DBUs in hours. So if my job runs less than an hour, or if it scales up for 5 minutes and then scales back down, do you know what the unit is that we're charged for? Like,
Yeah, we're charged at the per minute level. And the other thing is there is some startup time when you start a cluster, and you're not charged for that for all that startup time when you start a cluster. The charge starts when it's called the Spark context gets initialized. So there's a bunch of libraries loaded onto your cluster, and then the Spark context comes up, and that's when the charging starts. So you're charged at a fraction of a minute. So you're not, it's, you know, it's not lawyer billing at the 10-minute or hour intervals. You know, you just turn it on, is that scale up and scale down. So you don't have to worry about that scaling process. And that is where you see a lot of cost savings. And when we look at our customers that have migrated from other vendors, that's where we see a lot of that savings, is they don't have to have that full cluster up all the time, and they're charged at that minute.
awesome, thanks.
Yep. It looks like we have a question. Stephanie, can you unmute? Someone raise their hand. I'll continue on, and Stephanie, if you can unmute whoever raised their hand, if it's still raised, I'm not sure I can find that.
Yeah, so I let them talking permitted. So Shadar, you have to unmute yourself at this point. You should have the permission.
Oh,
no,
okay. Thanks.
that's okay. That happens.
Okay, and so this is what was just asked of the cluster considerations of what goes into those. And so we have that worker and driver instance type. Again, you can think about the CPU versus memory optimized, which is grouped in the GUI, but it's also available on the web page. And then we also have that number of workers that we talked about, of how you want to scale up. There is a standard versus high concurrency clusters. This is going to change a little bit if you're using Unity Catalog. So this might be something to deep dive with your account team if you have questions on the standard versus high concurrency versus Unity Catalog. Cluster ACLs is how the platform team or whoever is managing is how you can manage who has the rights to create clusters and start clusters. So if there's a big team, you have different policies that you can do. Cluster auto termination. This is what we saw over here. It is terminate after X number of minutes of inactivity. So this just means if nothing is running and the default is 2 hours, it's going to turn the cluster off. So you're not going to get charged for that. So you can play with that as that makes sense for your development time for your interactive cluster. There is some differences with the on-demand versus spot instances on the different clouds. And those vary on, again, what your requirement for your workload is. Can you take that spot instance, which is often cheaper versus the on-demand? And that's something that it goes into the VMs on the cloud vendor. So it varies between the different clouds, and some recommendations on if spot instances and you have a mission critical production pipeline, you might not want that. And then lastly, cluster tags is a way for the groups of people that have want to maybe do chargeback. You can put tags on your cluster so you can see how clusters are running, how long they've been up, and who's getting which groups are using them. And then there's it can help you manage those costs this way. So this is what someone was asking before, this goes for drivers or workers, but this is just an example of a couple of the AWS and Azure instance types of when you would look at those recommended use cases. The link I have in the document does go through deeper of the whole laundry list of the different memory versus compute optimized. Oh, and Stephanie has a much better correction, so my apologies. It is a pay per second granularity, not per minute. So it is more precise than I said. So thank you, Stephanie. Okay, and these are actually, we talked about this, but this is the number of worker nodes of where it is in that GUI. So you'll have this for reference. I'm going to click these next few ones that just kind of do these circles pretty quickly. But, when you're looking at those worker nodes, you can look at fewer big instances versus many or small instances. And that's where you start to do that experimentation, or you start with your first guess of what you think your data is going to be doing. And then you go through and you can look at the Ganglia and see how it's being optimized. So the general thinking is, you can reduce the numbers of machines. If you can reduce the number of machines, you can reduce the number of data that needs to go through the network. So when you're thinking of fewer big instances versus many small instances, you can reduce network traffic. Okay, and the number of shuffle partitions is, in general, if data is being shuffled, it's actually extra work that has to be done on the worker, so you have longer upper time, a little bit slower. And this, we have some deeper dives into the shuffle partitions, and we can see that in the Ganglia. And so this is stuff that if you're at this level, you're going to be looking at Ganglia, seeing if you have shuffle partitions and if you want to change that. This is pretty low level fine tuning. And, as we do move to some, especially for like SQL workloads and SQL serverless, this will be handled a lot more under the hood. And this is, again, one of the strongest recommendations for optimization performance, and then therefore cost, is to, if you can, try updating your runtime, because we get more and more built into the runtime. And the last thing is down here on that data set, you're thinking about how that data set's going to be distributed through the whole cluster that you have with the number of workers. And there is a little bit too when you're looking at the creating your cluster, and you can see that when you're creating your cluster, there are the different optimizations with the different caching and the different delta cache accelerated. These can be ones if you have a workload that you think caching is going to help, you just want to select that storage optimized. And then under the hood, these often use a different SSD versus maybe a less expensive and slower spinning disk. Okay. Oop. Actually, I am going to. So this is a little bit on just when I talked about those shuffle partitions. So depending on the type of transformation that you're doing, so thinking your data engineering, you may cause a shuffle to happen. So when this happens, all of the executors require seeing all of the data to perform the, in order to accurately perform the action in the shuffle. In a narrow transformation, the input and output stays the same over here, and no data movement is needed. So when this happens, this is, so in the wide transformation, the input from the other partitions are required. And so that's why they have these arrows. And you can expect this job to be much slower. So a lot of these times when these wide transformations are going to be group bys or distincts. So there is, again, at the end of this, some more coding practices, but this is some of those. If you're not meeting your SLAs, things are going slow, shuffle partitions are a place to look. So, and when you're going to think, if you're going to go down to looking at these shuffle type of partitions, you really want to think, you don't want to necessarily optimize for every single shuffle in a notebook. You want to look for your biggest impacts first. And again, look after you've seen if you're not making your SLAs or need to get this cost down. And real quick, this is a ballpark idea of how large should your partitions be. And so this is just the answer somewhere between megabytes to gigabytes. And so if your partition's too small, you might get unnecessary adding more tasks to your stage. We'll see that in the Ganglia. But if they're too big, you might get bottlenecked by the network. So this is just a, good starting place is to look at this. So what you do here is you would go and when in the Spark UI and look at your longest job. Click on that longest job, sort by the shuffle read, and then you get your largest shuffle read stage, and that's how you can get this largest shuffle. So it's in the Spark UI. Okay, so the driver nodes. Drivers don't usually do too much in the way of intensive tasks like the workers do. So they are usually the coordinator. The exceptions are these ones that we have here. The common exceptions are large data sets are being fully returned to the driver. The driver is doing heavy lifting for graphics or visualizations, or sometimes ML. The job is broadcasting large variables. And that means variables have to be collected to the driver first and then sent to all the workers. So that's sufficient. And in that case, when that broadcast, so bring to the driver, broadcast to the workers, you need to make sure your driver node is large enough to handle that. And a question that is commonly asked is, what is a large data set? And the rule of thumb is to try to not exceed 20% of the total memory in the driver node. And that leaves some room for the other tasks that that driver needs to do. So it needs to do other tasks of orchestrating and garbage collections and background tasks. So we talked a little bit about right-sizing the cluster, but this is also looking at the data when you're in development, especially. So when you're first starting a development cycle, there are some best practices of how you can actually speed up your work. Because again, the people doing the work is one of the most expensive costs. So an example is doing development. You might want to identify large data sets that you tend to work with. And then you can think about, for this initial development, when I'm doing some code iteration, can I shrink this data set down to a small subset, say 10% of the full size, so that you can just speed up this development. And then you can do some of your testing with your full data set size, but you can start the development much faster. And if there are multiple large data sets, if you're doing this, paring them down, you want to make sure that you select the same base key set so that the joins will be valid, meaning that the keys should match on the different data sets. So one of the ways to think about that is you might spend some time when you're starting development, maybe an hour or two of your time to get this data set pared down so that it can be stored easily through your development. But you're going to get benefits when you can get your iterative real-time development faster. You can cache some data sets, your queries return faster. You can use a larger and maybe more instant. You might not need to use that larger cluster to be able to do some of this. And it's easier to clean up mistakes when you're in this development. So then after you get some of the development, you can right size your full cluster a lot easier because you have some scaling ideas of like, okay, I use 10% of my data. I saw how these different workers and clusters work, and I can scale up faster. So you can do some extrapolation to that full data set. So you use that 10%, you can think that data set will be 10x the size, and then they determine that cluster that's necessary to handle more nodes of data. So I briefly mentioned the cluster ACLs. I want to deep dive a little bit deeper. So ACLs are access control lists. So access control lists allows the users and the admins to give that fine-grained cluster control with the cluster permissions of who can create the clusters, who has clusters to run the clusters. You can see in the drop down in the admin. So this is in the admin setting of who can manage and who can run and create. So, and it's also who can restart that cluster. So this really protects our customers against just wasting DBUs by accident. So these are the cluster level permissions that you can grant. So depending how your team set up, an admin might set up these cluster level permissions. You might have a data science team that sets them up. It's just really dependent for best practices on how your team is specifically structured. But know that these are here and they are a big help on managing those costs. So cluster auto termination, we discussed this really quickly also, but if you're just using a single cluster, you might change this down to like 30 minutes if it's just you and a cluster. Auto scaling, again, we went over this a little bit in the GUI. It just dynamically allocates workers based on the job. It adds both those worker nodes and that storage attachment. And so this is saying SSDs are solid state drives. These are fast storage drives. And in development, your time is worth that. So you can use that fast SSD. It's usually recommended to use that fast SSD for your development. Sorry. And then when you go to production, you could decide what speed you need. If you still want those SSDs, they cost more. And you see that in the drop-down menu of when you're creating your worker types. So this is that spot versus on demand. So on demand is an instance that you can fully control its life cycle. You decide when to launch it, stop, hibernate, reboot, terminate. And it is priced, again, per second of running, and it's predetermined price. Spot instances are unused instances that can be deeply discounted depending on market prices. So the price of each instance depends on your availability zone. This is in Amazon, and it's adjusted based on the availability in their long-term supply. So your spot instance runs whenever capacity is available, and the maximum per hour price for your request exceeds the spot price. So think of it as like bidding. So if you can use spot instances, that will likely save you money, but your workload is at risk of failing if those spot instances are revoked. So this is a risk reward of the pricing, and depending on where you are in your development, if this should be something you should consider. Cluster tags, this is where you can these different tags on the cluster that's created. And this is just key value pairs so that you can do either chargeback or just see how the cluster has been utilized. So department, project, line of business, person, these are common ways that we see people using these cluster tags.
Just real quick, I'm going to jump in. So I see a lot of my customers have been getting value out of this recently, just being able to understand which data science projects are using which compute, so that when they are talking about the ROI and the impact that their algorithms are making, they're able to then say, it's only costing us $2,000 a month to run this, but the amount of money that's being saved, the ROI is extensive, and helping them to be able to talk about the value that their team brings to the table.
Excellent call out. Okay, and then we have pools is another option. So pools reduce that cluster startup time and auto scaling times by maintaining a set of idle and ready to use instances. So the big takeaway is there are no DBU charges while these are in the idle pool, and the pool expands by allocating a new instance from the provider to accommodate the request. So it scales up and down. And then when that cluster releases an instance, it's going to return it to the pool, and it's free for another cluster to use. So only clusters attached to this pool can use the idle instances. So you just see those different pool names. So this is in the setup. You can go and select a pool. I am missing I thought I had a slide in here, and it's not, so I don't have a slide, but the other thing that we have that you'll see right here is another option is this photon acceleration. And Photon was re-architected for the fastest performance that we can get in the real world. And it was rewritten in C++ versus the Java virtual machines because it has its own custom built memory management, and it reduces JVMs. So when you see this photon acceleration, we often see this as a pretty big cost savings, and also helps your just throughput when you use that. So Photon is compatible with, completely compatible with the Spark SQL and data frames. So it works on your existing code. So you should be able to just click that box and then use the instances that have that photon acceleration. And that can be worth that acceleration can save you that time of uptime of the clusters.
We've got a quick question on here about multiple jobs running on the same cluster. I personally haven't tried to use Ganglia and look at those specifically when there's more than one job running. I don't know if you have, or if you've got comments on that, Carrie.
Yeah, there's let's see. I don't on the jobs, but what I can say is when we're looking at notebooks, I'm gonna open. This is just code. It's Spark review, so it's just running. There are some ways that you can look where you see these Spark jobs in a notebook. You can go and figure out and click this view, and you can start to you're going to see this. It looks like the Spark UI, and then you can look at the different stages, and you can look at the stage IDs, and you can figure what's happening on these cells. I'll try and look up how this happens with the actual jobs, because I'm not sure. You can find it. I'm just not sure offhand right away when we go to and look at the jobs in here, how you can look at these different jobs on the cluster. But when we go here, and that's, oops, excuse me, in the Spark. So I'll just hop over here and I'm going to show how we get to the Ganglia in the Spark UI. So I've got my cluster, this cluster I'm running, so I know actually what's been happening on it. You can look, the common ones I usually like to look at are the Spark UI and the metrics. So that Spark UI, this is that Spark UI. You saw I clicked through to it from the notebook, and that showed which notebooks were associated, or I'm sorry, which jobs were associated with those different cells. And then if you're running jobs on an interactive cluster like this, you'll be able to see the different jobs and you can click through. Again, I'm not sure when you're running a job from a scheduled job, how that works with the interactive. So I'll take a note to try and find that, you know, and we can send it out to the distribution list on that. Let's see, I see you've got another question. When a high memory job is scaling up from the start and the initial workers start using swap before the replacements are available, it seems like the first set of workers thrash. And let's see. I'll have to take that offline and dive a little bit deeper. Restarting the cluster is a workaround. Stephanie, if you can take a look in that chat, if you know that from Douglas, I'm not sure of that answer right now.
Okay, I can respond to Douglas.
Thank you. So this is kind of just a quick summary of some of those pricing considerations of persistent versus ephemeral clusters. So that's the ones that scale down and turn off on their own. So auto shut off, and then on demand versus spot, using your cluster policies and using pools. The monitoring of costs is, you can look at your usage overview. We have abilities to do log delivery and that chargeback with cluster tags. And our future roadmap, the monitoring of your costs, when you're not here interactive tuning, once customers are moving over to using Unity Catalog, we have what's called system logs. And we're developing a lot of usage metrics around these systems logs that can be used to import to a third-party tool if you want, or your own dashboards. So that's tied with our Unity Catalog release, because we have these right here with this usage log. And we also have what's called Overwatch, which is a way of just gathering these logs and making some standard BI tools, basically within Databricks, of dashboards to see what your actually cost is doing. So right now there's Overwatch. There's using these three we have here with log deliveries that you can do your own analysis. And then moving forward with Unity Catalog, we have a lot more called the system tables, where you have access to tables and it's a little bit cleaner and you can query and you can customize as you want. Okay. So performance and managing performance at when you're using Databricks. So right now, this is that system of tools. I kind of started clicking through it quickly, but it's really the ecosystem of looking at your Ganglia Metrics. We're going to hop over there next, using that Spark interface. Again, hop over next, updating your Databricks runtime, and then again, that code. So what I'm going to show, so right now I was showing some stuff, but I have this just cluster that I just created when I was doing some scaling, some ML pipelines work. But I'm actually going to hop over and look at the clusters that are accessible to me and our shared auto scaling clusters, because this is one that a lot of us SAs just hop on and take a look at. So if you see, I went to my compute, looked at my different clusters. We can see there's 14 notebooks attached to this right now, but the Ganglia is actually over here under metrics. And you see as this loads, you're going to see there's this link for the live metrics, the Ganglia UI, and these historical. These historical are literally snapshots of the main page of the Ganglia, and we're going to show the interactive part of the Ganglia. But what you need to know that these, you can't click on these and change what's, obviously they've used. You're going to just get what the default is, but just know that this is here if you really need to go look at a history and you don't have this cluster live. These have been snapshotted. But the Ganglia UI, so a little bit of an older feeling interface, but it actually has a lot of information here. So I'm going to walk you through some of the high level of how you look at this cluster. So this is this cluster. This is an auto scaling cluster. Up here on top, where you have these 4 graphs, this is a summary of the entire cluster. So one of the things to point out is a lot of times you're going to see the peaks and valleys, but this is again the summation of everything that you see down here. So it's a little bit harder to tease out what your drivers and your workers are doing just based on this, but you get that snapshot of what the entire cluster is doing. So, we talk a lot about memory, and we talk a lot of CPUs. So overall, we look that this cluster has been maxed out at 80% of its CPU, but hasn't ever hit 100%. But again, summary. So what I like to do is go down here and type the word report, because I can't remember if the report is first or after, but it goes through and you can see that we have the memory report and the CPU report. So let's just take a look at the CPU report. I'm also going to change these larger so I can actually see them. So here we have down here for each driver and worker that is in the cluster at this time, you have a separate graph for each. So you can see here that that CPU, it is hitting max right here. Now you look here, we have a couple of numbers. You're going to see a 43 and a 143. This is the IP address. You can guess at which one of these is the worker and the driver, but the way that I tend to like to go look at the worker and driver and know definitively which is look at the Spark UI. And then I go here and look at executors. And I'm going to look at sort on the status. And you can see here, this is, there's 2 active. I've got a driver that ends in the 143, and I've got a worker over here on the, just the 43. So I just look at those numbers quick and I just double check. And you can see that on this worker, there's an active task right now. You can look at, and again, these just have some of those information. I'm going to hop back to the other Ganglia so we can talk through that, and then we can come back here and look a little bit more at the Spark UI. So again, it's a little bit of looking between the Spark UI and the metrics, which is where the Ganglia lives. So here, now I just forgot. I said 143 is the driver. So I go back and look at the cluster report and say, okay, this right here is the driver. So here I'm seeing that this worker, for this task, this might be something considered to scale up the CPU or add more partition my data or somehow changes. So this is getting very close to 100%. So this is just starting to make me a little bit nervous that this is underscaled, because we're going to hit that peak and be waiting a little bit. we do a similar, I look for the memory port. Same thing, we're going to look at, where our maximum memory is. And it looks like this is pretty good on our memory. There's not too much. We can see here that you've got the usage and share and cache and buffering, and you can start diving into these. So again, I just clicked on the worker here, and then we're going to start to see the next layer of the different metrics that go on this worker. So that other one is our summary page, and I'm just diving into the internal load, the memory, the CPU, and the network. So if bottlenecks are happening, this is where you're going to start to look at where we have possible bottlenecks. Disk space available, total disk, and just diving into, can we optimize this better if this is a problem for this, especially job or workload that we need to run faster or be more cost efficient. A couple of things like I did show, because I know we're getting towards the top of the hour. And go back to when you're doing the interactive development. Again, just reminder of, if you're saying, just looking, I just did a very big, it's very simple Spark data frame. When you're in your code and looking like, hey, this took 0.77 seconds, but there is no Spark, it's because the way Spark does a lazy execution, you have to actually touch that data. If you just do some transformation, Spark's going to say, you don't actually need anything yet. Let's wait till you need to collect or sample or do something with your data. And then Spark's going to go underneath the hood and optimize all these different transformations you did. So if I just did, a couple of renaming and casting here, but I didn't tell it to do anything. It's just saying, I have a plan. I'm going to execute this, but I'm going to wait and see if you're going to add more to this transformation. And then when I execute, going to optimize for you. This is one of the powers of having these multiple APIs and how you can switch between Python and SQL, and Spark's going to compile it all down to the code that it can distribute. So you don't have to think about it. Spark's going to think about it, and it's going to translate your language down to the language you can understand. But you can start to see the jobs here. If you want to start enabling, this is where you can see that, executors and the drivers added, the stage. And then actually it's on this job 8. If you want to start clicking on what's actually happening here with the code gen, this is the details for what happened on this stage 8, and you can start clicking through and see the actual partitions that's happening. The timeline, you can see, the statistics and aggregated by the executors. So again, development, this is really powerful. Just remember, this is here so you don't have to go directly to your Spark UI. You can start here and see how these different cells are executing. And you can see the peak memory, shuffle times, and this is where you can get that feel for these parts that are sticking a little bit or you're having delays. And so, the shuffle right size. And with these summary statistics, I do want to say that in the Spark docs, if you look here, this is the documentations for the web UI. And this tells you, some of those stage details. This will help you understand what's happening with that UI that we've talked about, of what these different details mean. This shuffle read records, it goes into this detail. So you want to deep dive and understand what's happening and that you're seeing. This is just where, remember, just the Spark open source docs, and it's the web UI link. Okay, we are at the top of the hour. Do we have what I do want to show here, because we're going to send these out afterwards, is in here we do have what I talked about with the Ganglia Metrics, so you can have this for your reference. And I do have how you design this foundation that I showed at the beginning of small file problems, data skew, we got links in here. Again, the data skipping, these are a lot of things, the best practices of your actual data. And then how we do the processing, how we can update that. And I've got some information here in your code optimizations. I'm not going to read through these, but they'll be sent out. And then here's on the end of this, I have also just a couple of links. I have that Spark UI documents linked. This is a course that we have through our Databricks Academy, the Optimizing Spark on Databricks. The instructor-led class is a charge, but it is a very good class where they'll go through and teach you how, I have a spill here. What do I do? How do I have these best practices? So I think it's a 2-day course. So take a look at that if you really want to deep dive. And then we have the other links on Ganglia and Spark, cluster optimization, and what is Ganglia, and Spark UI. So with that, I have a couple minutes left. I think Stephanie has been handling some of those questions. So thank you for that. And as always, your Databricks account team is here to help you. So if you have any questions about this after you get sent out, reach out to your account team. If some of this seems complicated, know that we are working on serverless SQL, so we can do a lot of this optimization for you and you get some faster turn-up time. So there's a lot. And then also on our roadmap, we're really looking at that visibility for our customers to be able to see their usage and track their usage, because everyone's talking about cost savings these days with this economy. So with that, I want to thank everyone for your time.
Thanks so much, Carrie. Really appreciate you presenting today. And then if anybody on the line has questions, don't hesitate. We're here to answer questions. But this was really helpful, Carrie. I think you had a lot of the big points, and probably the most important takeaway, I think, is always the runtime. If you're on a 5.3 runtime, you're not getting any of the optimizations that we've come up with in the last year. So with that, it looks like we got a couple in the box. Let's see. Is this recording available? Yes, we are going to send out the recording after this. I will also include a copy of the slides.
And the other quick question is, can you differentiate between jobs and tasks in an interactive cluster? Yes, you can. You can do that in a Ganglia. And I also, little sneak preview for the class, they do tell you actually how you can do some labeling of some jobs and stuff in your code too, which can be very beneficial for troubleshooting. So again, thanks everyone.
Awesome. Have a great day. So for Naveen, you haven't received any of the prior recordings for the events. Can you send me an email at Stephanie